Good morning, students. This lesson is of class 9 for the subject of physics, topic measurement of atmospheric pressure, which is covered in chapter 4, pressure and fluids and atmospheric pressure, given on page number 96 of your physics textbook titled Concise Physics by Selena Publications. This lesson is submitted to you on 12th July 2021. Students, as you all know that temperature is measured using thermometer, weight is measured using spring balance, instantaneous speed is measured using speedometer. Children, similarly, barometer is an instrument, barometer. Underline this in your PDF also, barometer. It is an instrument which is used to measure atmospheric pressure. So which device is used to measure atmospheric pressure? Barometer. Barometer is a device which is used to measure atmospheric pressure. So there are three types of barometer. Firstly, simple barometer, 14's barometer, and aneroid barometer. Children, the basic principle of all the barometers are same. Now coming to simple barometer. Torseley, it was the name of a scientist. Torseley designed a simple barometer using mercury as a barometer liquid, as shown in figure number 1. In figure number 1, at point C, this is point C, point A, point B. So at point C, the surface of mercury in the trough, atmospheric pressure is exerted at point C. At point A, there is also a pressure, but that pressure is due to, at point A, there is also a pressure which is due to weight of mercury column, this thrust. So due to weight means thrust in this case, thrust of mercury column above it. Initially, the gas tube was having vacuum. Originally, this glass tube was having vacuum inside it. Thus, the pressure in the glass tube is less. Originally, the pressure inside this tube was less. Why? Because it was having nothing here. It was vacuum here. So their pressure was very less. And as we have studied earlier, that the fluid flows from high pressure to low pressure region. So the mercury will start rising in this glass tube, and it will rise up to a point where the pressure at point C and at this height becomes same. So with this height, we can calculate the atmospheric pressure. Now children, mercury, this is what I was saying you. The mercury will rise in the glass tube as fluid always flows from high pressure to low pressure region. And this flow continues till the pressure of both the region is equal. So mercury will rise till the pressure in the glass tube and the trough becomes equal. And thus, children, mercury will rise up to a height h in the glass tube. Now further, students, the height up to which the mercury rises in glass tube is known as barometric height. And the space left empty above the mercury column in the glass tube is called Torselian vacuum. So students, in figure number 1, the place where there is nothing yet, there is vacuum here above point B. This vacuum is known as Torselin vacuum. So children, now note that if atmospheric pressure decreases, then the vertical height of the mercury column in the tube also decreases. That means mercury doesn't rise much in the glass tube. Thus, the vertical height of mercury column from the mercury surface in the trough to the level in the tube is the measure of atmospheric pressure. Students, the barometric height at normal temperature and pressure at sea level is 0.76 meter, which can be written as 76 centimeter of mercury. Now, what does it mean? Means that at normal temperature and pressure at sea level, normal temperature and pressure at sea level, the mercury will rise up to a height of 76 centimeter, or you can say 0.76 meter, which can also be said as 760 millimeter of the vertical glass trough. Now children, you may pause this session for 5 minutes and observe figure 2. Can you see any change in the level of rise in mercury, even if the tube in barometer is tilted? See figure number 2. Now there are two tubes. One is raised vertically and the other is at a certain angle with horizontal. So can you see any difference between the level of mercury column? So your answer must be no, that no, there is no change in atmospheric, there is no change in level of mercury column in the two given conditions. Now children, the barometric height at a place changes only when the atmospheric pressure at that place changes. If atmospheric pressure is different, then barometric height will be different. Thus, barometric height remains same even when the shape of the tube is changed or the length of the tube submerged inside the mercury in the trough is changed, or if tube is tilted from its vertical position. As it was shown in figure number 2, even if it is tilted, even if the tube is tilted, still the mercury column is having same height, because if you tilt this tube, the atmospheric pressure is not changing. Height of mercury column will change only if there is change in atmospheric pressure, else it will not change. Children, in an accurate barometer, the empty space above the mercury column in the tube is called perfect vacuum. But if air or water droplet, which will immediately change into vapor in the vacuum space, if this thing enters the empty space, so the water droplet will exert pressure at the top of mercury column, due to which barometric height will decrease. Now, such a barometer is known as faulty barometer. And the barometric height of a faulty barometer will be always less than the atmospheric pressure. So children, in this figure number 1, if instead of vacuum, you are having few water droplets, or you can say gas, air bubbles, so what will happen? These water droplets will convert it into vapor since it is vacuum, and then they will start applying pressure on the mercury tube. When they'll apply pressure on this mercury height, then what will happen? The level of mercury will decrease, and you will see the atmospheric pressure a little decreased than its original value. Such a barometer is known as faulty barometer, and the reading given by the faulty barometer is always less than the actual reading of atmospheric pressure. So to avoid this, we have to create a proper vacuum at the top of mercury column. Now children, the question comes that why only we use mercury as barometric liquid? Because mercury is having certain advantages over any other liquid, and these advantages are, first of all, the density of mercury is high, and its value, you have to learn the value of mercury. The density of mercury is 13.6 multiplied by 10 raised to power 3 kilogram per meter cube, and instead of 10 raised to power 3 kg per meter cube, you can write down simply gram per centimeter cube also. We can say this thing that 10 raised to power 3 kg per meter cube is 1 gram per centimeter cube. Students, this conversion was done in class 7th. 1 gram per centimeter cube. Now kindly remember it. It is actually equal to 1000 kg per meter cube. So instead of 1000 kg per meter cube, you can simply replace it with 1 gram per centimeter cube. So children, for 1 atm, that is 1 atm means 1 atmospheric pressure, that is 1.013 into 10 raised to power 5 pascals, only 0.76 meter height of mercury is needed to balance 1 atm pressure. So if we use the formula which we did in first exercise, P is equal to H rho G. So how to write down H? P divided by rho into G. So put the value of pressure here, put the value of density, and acceleration due to gravity, take it to be 10. So your near about answer comes out to be 0.76 meter, that is 76 centimeters. So mercury at 1 atmospheric pressure will rise up to this much height. Secondly, the vapor pressure of mercury is negligible. So the vapors in the torsilon vacuum does not affect the barometric height. So vapor pressure of mercury is very less. So if you are having any vapors in the vacuum, torsilon vacuum, then it will not decrease the height of the mercury and you'll get an accurate answer. Thirdly, the mercury neither wets nor sticks to the glass tube. Therefore, it gives accurate reading. Students, if you see a thermometer in your house, there also mercury is used as a liquid and it expands due to heat because of high temperature. You might have observed that there also mercury does not stick with the glass in which it is contained. The surface of mercury is quite shiny and opaque. Therefore, it can be easily seen while taking the reading. And the last advantage is that it can be easily obtained. It can easily be obtained in a pure state. And we need the barometric liquid to be pure. We don't want any impurity inside it. Then students, the question arises that why we cannot use water as a barometric liquid. What is the problem if we use water as a liquid? So children, first of all, the density of liquid of water is less. It is only 1000 kg per meter cube, which is 1 gram per centimeter cube, while mercury was having value as, the value of density of mercury was 13.6 gram per centimeter cube. So in comparison, water is having less density. And for 1 atm, that means 1.013 into 10 raised to power 5 pascals, for this much pascals, your height, how much height you need? You will nearly need 10.4 meter height of water column. Now Mercury was needing a height of 0.76 meter, 76 centimeter, or you can say 0.76 meter was the height of Mercury column. But here the water will rise up to this much height. You put the formula of P is equal to H rho G and you find the value of H in this case yourself, please. The value of P is 1 ATM converted into pascals. Density, take it as 1000 and take G as 10. If you put the value in the formula, you'll get height as 10.4 meter. So what does it mean? You have to make a column of water approximately of a height more than 10.4 meter. So it is very inconvenient to make such a big glass tube. And it will be tough to handle also. Secondly, the vapor pressure of water is very high. So its vapor in the vacuum space will make the reading inaccurate. We need a liquid whose vapor pressure is less. Water is having high vapor pressure, while mercury was having less vapor pressure. Moreover, water sticks with the glass tube and also wets it. So the reading will again become inaccurate. And the last is water is transparent, children. So its surface is not seen easily in the glass tube while taking the observation. So that's why we don't use water as a barometric liquid. So now children, you are required to go through all the notes provided and then read this topic from your book also. And moreover, your homework is kindly do the tick mark questions on page 101. All these questions have been discussed in your PDFs also, and they'll be found very easily. Only one thing has to be kept in mind for question number 5th and 7th. The reasons should be the fluid flows from high pressure to low pressure region. So with this, I come to an end to this interactive session. Thank you, students, and have a nice day.